Hello friends, today we are going to calculate the slope and deflection at this free end using the conjugate beam method in terms of EI. Now for using the conjugate beam, first we have to convert this given beam into conjugate beam, and according to the definition, the length of the span is similar in the actual beam and conjugate beam. Hence for the conjugate beam, our span length is as it is. Now support condition is changed from fixed to the free, and free becomes the fixed support. And the next change is the moment over EI diagram of actual beam converts as a loading in the conjugate beam. So first we have to calculate the moment. So at location C, our moment is 0. If we take the point B and calculating the moment in the right hand direction, then at location B our value is 30 into 3 into 3 by 2, and sectional right hand side clockwise moment is negative, hence our value is minus 135 kilonewton meter. So at location B the value is 135, and if we take the moment at location A, then it is as 30 into 3 into 3 by 2 plus the CG distance is at 2 meter. So 2 plus 3 by 2, but it is in negative, and the total value is minus 315 kilonewton meter. So at location A, total moment is 315 kilonewton meter. Now in between A to B there isn't any point load, hence we have to connect these 2 points by the inclined line, while for the UDL we have to draw a curve or parabolic curve in between B to C. And this value must be divided by flexural rigidity as a EI. So the M over EI diagram is converted into the loading in the conjugate beam. Now we have to calculate the slope and deflection at the free end. It means at location C. So corresponding location in the conjugate beam is C dash. So for the calculation of slope at C in the actual beam, which is given by shear force at C dash in this conjugate beam. So shear force at C dash, and if we take the left hand side direction, the loading is in the upward direction, so our value is positive. Now the first value of the curve having the total loading as a 135 by EI and span length as a 3 meter, our total loading for these types of curve is 1/3 into rate of loading as a 135 by EI and distance as a 3 meter. Now for the second part, which is F trapezoidal, if we convert it into two part as a this 135 by EI for the rectangular part or UDL, and the rest value which is 315 minus 135 as a 180 by EI which is of UVL, then for the first part it is of 2 meters, so the total load is 135 by EI into 2, and for this triangular loading the total load is 1/2 into 2 meter as a distance, and the rate of loading is 180 by EI. And the slope at the free end of actual beam, which is 585 by EI in terms of kilonewton meter square. Now going ahead for the calculation of bending moment corresponding to the deflection at free end of real beam, we will have Now for the deflection at the free end, we have to calculate the bending moment at same location in the conjugate beam. So it is so at location C dash, the parabolic curve moment, which is total loading as a 1/3, the rate of loading as a 135 by EI, and the total distance is as a 3 meter, and CG distance from the C dash, which is 3 by 4 of the distance. Now for 135 by EI rectangular loading, or we can say that the UDL loading, it is 135 by EI into total distance as a 2, and CG distance from the C dash, which is 3 plus 2 by 2. And the for UVL of 180 by EI, it is total loading as a 1/2, 180 by EI into distance as a 2 meter, and CG distance from the C dash is 3 plus 2/3 of 3. Now solving this term, and the deflection at free end as a YC, which is 2163.75 by EI in terms of kilonewton meter cube. So thus we can calculate the slope and deflection of the given beam by converting into the conjugate beam. Thank you.